My name's Joelle and this is my partner,
Nadine.
Okay, to start this off, I'd like to ask whichever of you left-handers are, please raise your hand. Well, there is only a 1 in 10 chance of being left-handed, and 8 in 10 of those are usually males. Okay, so we are a small lot, but don't worry. People like Jennifer Lawrence all the way up to Barack Obama are left-handed, so we practically rule the world.
That's honestly debatable considering right-handers dominate 87% of the world. So we didn't leave much for left-handers. Okay, and whoever's right-handed, raise your hands. So clearly we're the majority. So left-handers, do you think you're better at maths?
And what of the right-handers? Our experiment was to find out whether handedness influenced a person's mathematical ability. We wanted to better understand the effect of handedness on math, using data collected from school reports to settle conflicting hypotheses regarding handedness and brain ability.
But what is handedness? It's simply the preferred use of the right hand, the left hand, or the other, one or the other, depending on the task. Though some scientists believe that there's only 2 types of handedness, right and non-right. These researchers believe that true left-handedness is rare and that most left-handers are really mixed-handed. But I just think we're all simply right or left-handed, and we use that criteria to base our experiment on as it's more renowned and there's more research to back it up.
Okay, so let's give statistics. So it's commonly estimated that about 10% of the human population is left-handed or right ambidextrous, and the boys are about 1.5 times more likely than girls to be left-handed. Archaeological evidence indicates that about 30,000 years ago, the left and right-handed people were about the same. And back then, left-handers were often forced to use their right hand for daily activities. Back then, being left-handed was thought to be caused by numerous physical, psychological, and even supernatural causes. I would not have survived back then, but modern science has discovered there are some other causes of types of handedness, including it arising as part of the developmental process, and that differentiates the right and left side of the body, called right-left asymmetry, and the lateralization, which is the function that each hemisphere of the brain has. It was initially thought that a single gene controlled handedness. However, more recent studies suggest that multiple genes, perhaps up to 40, contribute to this trait. Each of these genes likely has a weak effect by itself, but together they play a significant role in establishing hand preference. Studies suggest that at least some of these genes help determine the overall right-left asymmetry of the body, starting in the earlier stages of development.
There's also some people who believe that handedness is affected by prenatal environment and cultural influences. But honestly, if there's no science behind it, what's the possibility that it's true? According to every science teacher and scientist, 0%. Okay, so we chose the age group 11 to 15 years old, which is grades 7 to 9, for this experiment because young adolescents are easier to test for mathematical ability because they're constantly partaking in mathematical courses and are being tested because they're still in school. And research has discovered that young adolescents are more likely to volunteer in research due to the risk-taking nature of their behavior and eagerness to participate.
Our results did slightly differ. Our research is different to these past scientists because our research focuses on the skills that each subject has regarding handedness, and the test is specifically meant for the 11 to 15 age group. It benefits the society to help differentiate between people based on their handedness, and it helps neurologists and biologists understand furthermore how handedness influences the right and left side of the brain and everyday logical thinking.
When finally calculating our results, we found both big and miniature differences that were quite interesting. But first I'll tell you what we thought would happen when we complete this experiment. So we expected that being right-handed increases your mathematical abilities while being left-handed decreases your mathematical abilities.
Our results did slightly differ from our hypothesis, which we'll further explain later. So the purpose of doing all this work for this experiment was so we could explore the idea of handedness and analyze the effects of the way it influences mathematical ability and psychology behind the way it influences the human brain. And maybe find out why I'm so terrible at math, because I have no idea what I'm doing in my class.
But our real inspiration was the fluctuating results of students and their performances in maths. We noticed that some students working at the same level of academic performance as others may excel naturally, and maybe that was due to their handedness.
But we did have to be careful of some factors in the experiment, like confidentiality, because we knew that many did not want their math marks to be known. So we had to make sure we never knew whose math marks were whose. But truthfully, I really wanted to know who got 95%.
And for this experiment, we only focused on the boys as we saw more of a variety of marks in this sector, and it's 1.5 times more likely for boys to be left-handed than girls, thus evening out our survey. Sorry, girls. Okay, but this experiment was really simple. All we needed were some test subjects, math percentiles, a handedness survey, and Microsoft Word.
Okay, so the experiment was quite straightforward to do and follow. We simply collected the list of names of all the male students in Amity College, and in the age group 11 to 15. Then a survey was carried out to determine the handedness of each test subject. Next, a table was constructed to collect the name, age group, first name, last name, handedness, and math percentile column for each of the test subjects. Afterwards, we sent the table to each age group's coordinator and with random identification numbers, so the students were anonymous. Finally, we compared the results of the math scores by averaging the math score and arranging them according to the handedness and age group.
So the students were tested based on the average of math scores over 3 terms, which means there were 3 trials/exams carried out over the time period. This experiment can be replicated easily over a 6-month time frame, and this allows repetition to acquire valid, accurate, and reliable results.
But the annoying part was that we had to make sure that all students were tested under the same conditions and were taught equally in the same way, and also they had to be taught by the same school with the same curriculum, so the results were consistent.
And that's basically what we did. So we had to make sure the handedness of each test subject was changing to have both left and right-handers.
And we had to measure the average mathematical score of each test subject, which took more math, and really, I just got her to do that.
It's okay. I saw it coming. Now, while running something like this, it may seem that there are no risks due to our lack of physical equipment, but the awareness of the risk it may have on students in this experiment is highly important. Some students may falsely come to identify themselves as having a complete lack of abilities and intelligence, leading to psychological demotivation or academic performances. Others may have no desire to participate in research projects which conclude that individuals like them are deficient or targeted at. So, for example, in this experiment, we hypothesized that left-handed individuals have less mathematical ability than right-handers, hence making them feel belittled. Boredom, mental fatigue, embarrassment at poor performance in tests or frustrations are minor, but common risks as well.
After long, tiring, and very sick days for her, the experiment proved that left-handers do have a mathematical advantage, as we found that left-handers were found to have a better math score than the right-handers in most cases. It also demonstrates that the higher the grade, the higher the math average is for the left-handers, as we see in the results table above. The minimal and statistical comparison between the overall average of results for the left and right-handed students proved that students were given the same condition and tested under similar circumstances with the same curriculum.
Overall, when the results were averaged together, we found that the left-handers had a small advantage at mathematical ability, as we found that there was a 0.4% difference between left and right-handers, making the left-handers have the benefit. Don't get too excited, left-handers, it's just a small difference. Now, before we actually ran this experiment, there were plenty of the people before us who actually theorized about handedness and experimented, but with different results. By using the scientific method, our experiment has contradicted a 1967 study by Douglas, who found no evidence to correlate mathematical ability with left-handedness or ambidexterity. The study compared the people who came in the top 15% of a mathematical examination with those of moderate mathematical ability and found that the two groups' handedness preferences were similar, but it did find that those who came lowest in the test had mixed hand preferences. If this claim was true, then there would be a big gap of difference between the right and left-handed, which is shown in each of the year levels. But when the results were averaged, the study seems to make more sense, since the difference is a small one. This may be a consequence of the mediocre amount of test subjects we use, or just plain coincidence. Actually, nothing in science is ever a coincidence.
So, were there any theories that matched our experiment and what we did?
No, not exactly, but there is a theory that matches our results and explains them in further detail. A genetic theory of handedness, the right shift theory, associates differential patterns of cerebral functioning with contrasting handedness groups and suggests that individuals with an RS++ genotype will be disadvantaged in maths. This hypothesis is investigated with contrasting handedness groups drawn from a national sample of over 11,000 children from the National Child Development Study. Evolution may be in the process of delivering a new age of genius and creativity, with left-handers leading the way.
Professor Chris McManus of University College in London has been researching the subject. He says that left-handers' brains are structured differently in a way that widens their range of abilities, and genes that determine left-handers also govern the development center of the brain. The professor says that the increase in left-handed population could produce a corresponding intellectual advance and a leap in the number of mathematical, sporting, and artistic geniuses. This does link with the right-left shift theory, as it is likely that these right-handers may have an RS++ genotype, which will give them the disadvantage in mathematics, while left-handers may not have this gene and would give them the upper hand in mathematics. This proves that left-handers may be structured differently in a way that widens their range of abilities and without the RS++ genotype, making left-handers naturally better at math.
Well, after reading about a lot of theories proposed by other scientists, we noticed that our experiment results were either very similar or very different, like two ends of the extreme. So this could have been due to the fact that our experiment wasn't carried out on females to study the difference between right-handers and left-handers on different genders. However, we ensured that the marks calculated were based on the same exams and assignments. So this was necessary to ensure that all students were being tested at the same level and tested for the same material and not different levels of assessments.
The experiment proved that left-handers do have a mathematical advantage, overall 0.4% over right-handers, and there is 3 different studies/theories that contradict our experiment. As we have proven, there is a slight difference between left-handers having a more advantage ability at math. In Year 7, there was a 6.2% difference between the left and right-handers in benefit of the right-handers. In Year 8, there was a difference of 11.2% benefiting the right-handers, and in Year 9, there was a 10% difference between the lefties and righties in advantage of the left-handers. Although in Year 7 and 8, the right-handers' scores were higher than the left-handers, the 2 grades were matched each other because the Year 9 left-handers had a higher average than both. Also, it proves theories according to the specific genotype RS++ and brain structure. The most likely explanation for this is that left-handers' brains are structured differently in a way that widens their range of abilities, and the genes that determine left-handers also govern the development and language centers of the brain, as opposed to right-handers.
So some of you are probably sitting here thinking, well, why should I care? How does this affect me? This experiment helps to expand on the knowledge and past experimentation behind the mystery of handedness. The study between handedness and brain capabilities has been a short-lived one, and there's no existence of a proven scientific theory by any scientist. It also helps to break down some of the myths about left-handers, like that they're more introverted, intelligent and creative when they're proven to be by experiment more mathematical, or that left-handers die earlier and suffer more immune diseases as well as more commonly dementia. No offense, it's just a myth, everyone.
Left-handers are also twice as likely to get schizophrenia or mental disease than right-handers, and that's sort of offensive. This experiment has overall allowed a further view into handedness and its effect on the humans and the brain. So the next time you're having an argument with a friend over who's smarter, just keep in mind handedness is probably a good argument. That is, if you're left-handed.
Thank
you.